Hello Year 11. Today I want to recap the sine and cosine rules and the area of any triangle. Now I'm sure we remember this to some extent because, as I'm sure you remember, Munir did a very good example of these for us in the last lesson before Christmas. So it should be quite fresh in your memories, but I'm going to go over it anyway because this was it was actually the worst answered question on paper 3, was finding the area using the sine and cosine rules. So I'm going to recap what that is for a generic triangle, and then there's 3 documents I've put up. I don't want you to do all of the questions from all of them. I have said in the description on Show My Homework which questions you should do because I only want you to do the complicated ones, not the very standard ones. So, sine and cosine rules and area of a triangle. I'm going to rub that out now to give me a bit more space. The generic triangle looks something like this. It needs to have no special features. So it's not an isosceles triangle, it's not a right angle triangle, because it needs to fit for absolutely any triangle at all. So label all the angles, A, B, C, label the sides with the same letters but lowercase, and then we will have sine rule, which is sine A over A equals sine B over B equals sine C over C. And as I'm sure you remember from that last lesson of term, you can also flip this, so it can be A over sine A equals B over sine B equals C over sine C. Cosine rule. We have got A squared equals B squared plus C squared minus 2BC cos A. If you want to find the angle instead, you can rearrange that. So you will have cos A equals B squared plus C squared minus A squared over 2BC. Finally, the area of any triangle is going to be half AB sine C. Now, all of these, well, this one you can't really start switching them around because if you replace A with another letter, you just get another part of the equation. This one, however, you could make this B squared, and then you would just replace the B's on this side with A's and this angle with angle B. You could make it C squared, and then you'd replace the C's on this side with A's and angle A with C. So you can, it doesn't necessarily have to be side A that you find. You can replace this with B and then swap in the A's on this side if you want to find side B, or you can just relabel the triangle that you're working with so that it will fit this formula. Same here. What this is really saying for the area is that is half AB, so 2 sides, multiplied by sine of the angle between them. So you could also have half BC sine A. That would work. Whatever these 2 sides are, this angle has to be the missing letter. So we've got A, B, C, A, B, C. So the other one you could have, but I don't have space, is half AC sine B. I am not going to do a lot of examples of these because we have recapped it a few times. I'm going to do an example from the area document. So I am going to do question 5. Question 5 is a triangle that looks like this, and we are told that the area of this triangle is 70 centimeters squared. And I need to find the value of x. So I know that the area of a triangle is half 2 sides multiplied together, multiplied by the angle between, sine of the angle between them. So I know that half times 16 times 11 sine x is going to be 70, which tells me that 16 times 11 sine x is going to be 140. And if I put that into the calculator, that should give me that x is equal to 52.7 degrees, because if you look back in the thing, it's asked me to do it to 1 decimal place. So all I've done there is use the equation that I know for an area of a triangle, and I've filled in the blanks. The one I'm trying to find is x, so I have to rearrange at the end to get x equals something else. Now, that was a fairly easy question that I've just gone through. A question that would be a little bit more like the one that you did in paper 3 is question 8 from the sine rule document. So I'm going to do that one next. In this question, we've got a triangle which looks like this. We've got two angles, 105 and 48, and we've got a side length of 13.1. And what we are trying to find in this question is the perimeter of the triangle. To find the perimeter of the triangle, we need to find the two missing sides. We want to find this side, and we want to find this side. So for x, we know that x over sine 48 equals 13.1 over sine of 105. So that is just using the sine rule. That means multiplying through by sine 48, x is going to be equal to 13.1 times sine 48 all over sine of 105, which means that x is going to be 10.0786 blah blah blah. And I am going to save that, even though it's a length, I am just going to save that for now. Now I can work out this missing angle here, because this is a triangle and I've got two of the angles. So this missing angle here is going to be 180 minus 105 minus 48, so it is 27. So that is 27 degrees. And then I can use that angle to find y. So in much the same way I did here, I know that y over sine 27 equals 13.1 over sine 105. And again, I would just multiply through. This would give me that y is equal to sine 27 multiplied by 13.1 over sine of 105, which is 6.157, blah, blah, blah. So I want to do the perimeter. I want to do 13.1 plus x plus y, and that gives me 29.3 meters to 3 significant figures, which is what the question asked me for. So this is a slightly more complex question, not very, but it's not asking you to just find a missing side, it's asked you to find the perimeter. So from that you had to deduce that you needed to find both missing sides, and you needed to use the sine rule twice. You also needed to use the fact that angles in a triangle add to 180. I'm not going to do an example for cosine rule because it's the same sort of principle. What I am going to do instead is remind you about different sized angles when we're using sine and cosine. If you look at question 10 in the sine rule document, the last question, so question 10, it says that angle ABC is obtuse. Now, the reason it's telling you that is because you need to remember that when we are using the sine graph, this is one period of the graph. So this goes up to 360 degrees. This point here is 180 degrees. And the graph repeats. So if we were to extend it this way, it would be the same pattern again, and this would be negative 180 degrees here. When you input sine inverse into your calculator to give you an angle, it only gives you values between -90 and 90 degrees. So for example, if I do sine inverse of 0.5, so 0.5 is here, sine inverse will give me 30 degrees. But that is an acute angle. If I wanted it to return an obtuse value, I would need to use the symmetry of the graph. This is a symmetrical arc. So if this gap is 30, then this gap is also 30. So whilst sine inverse of a half will give me 30 if I put it into the calculator, because that's an acute angle and I want an obtuse angle, I would need to subtract it from 180 to find the obtuse angle, which would be 150. So just wanted to remind you about that for question 10, because where it's asking you to find an obtuse angle, you are going to need to do something like this rather than just using the value that comes out of your calculator. In the same way, I don't think we've got any questions that are like that use cos, but as a reminder, if you put cos inverse into your calculator, again, it will only give you values oops, I've done nonsense. Sorry, everyone. Red line in the wrong place there. It needs to cover from here to here, so -1 and 1. So if you put cos inverse in the calculator, it's only going to cover this arc here. So it will cover from 0 to 180. So the type of question you might get on a cosine graph is that they want a reflex angle. So your calculator will return acute angles, so between 0 and 90, and obtuse angles, so between 90 and 180. But the question may want you to find a reflex angle, which is between 180 and 360. So again, you would then have to use the symmetry of the graph. You could use the angle and subtract it from 360, for example. So if you do cosine inverse to find an angle in this section, if you subtract that angle from 360, it will give you the corresponding reflex angle. That should be enough information now for you to do the questions. So what I would like you to do is question 6 onwards on the area document. Question 7 onwards from the sine document, although I've done question 8, so you don't need to do that. And then questions 9, 10 and 11 from the cosine document. Again, if you get stuck on any question, please just drop me a note on Show My Homework and I will put up a video for any of the questions you've got stuck on.